In this video, I'm going to introduce you to synthetic division. It's a way that we can divide polynomials a little bit faster than long division. But first, let's just review long division so we can appreciate how much easier synthetic division is. Let's say that I'm trying to divide x cubed plus 4x squared minus 5x plus 5. I'm trying to divide this polynomial by the binomial x minus 3. For long division, we always start with this guy. We're going to say how many times does this go into all of these terms. So x to the first power goes into x cubed x squared times. And we always line them up with our degrees on top of each other. And then similar to long division with just numbers, we multiply this by everything over here and subtract to find our remainder. So x squared times x is x cubed, and x squared times negative 3 is negative 3x squared. Now remember that we're subtracting this, so if we distribute that negative, we have a negative x cubed, and now we have a positive 3x squared. So we can write that instead. And now just combine top to bottom, so we don't have any more x cubes. And we now have 7x squared. Drop the next term down, similar to long division with just numbers. And then repeat the process. So how many times does x go into 7x squared? 7x times, and multiply everything. So 7x times x is 7x squared. 7x times negative 3 is negative 21x. And then if I subtract it, this becomes positive, and we combine our like terms here. So 0 there, and we now have a positive 16x there. And bring the last term down. So anything we get after this will be a remainder. How many times does x go into 16x? Well, it goes in 16 times. 16 times x is 16x. And 16 times negative 3 is negative 53, I think. Is that right? No, negative 48. My bad. That would be crazy. 48. We're subtracting, so everything becomes the opposite. So there we get 53. And we don't have any more terms to bring down, so this must be our remainder. And if you haven't already seen it, sometimes you'll see remainders written as quotients. So 53 divided by x minus 3 would be what's left over. So there would be our final answer. And it's kind of complicated and difficult to get through. I'm going to show you synthetic division, which will make this whole process hopefully a lot easier. So we'll do the same problem here, just using synthetic division instead. Alright, when using synthetic division, you're going to set something up like this. We're going to have a little box here. We're going to put a number in that box. We're going to have a list of coefficients here. So all of the numbers that are in front of your letters in your long polynomial. Coefficients, you're going to list those numbers there. We're going to be doing some multiplying and adding. And eventually what we're going to get down here is going to be the coefficients of our quotient or our answer. Coefficients of our answer. Okay. So if you want to go ahead and set that up, and I'll rewrite our polynomial, and we'll plug everything into the right spot and go through the process. So we had x cubed plus 4x squared minus 5x plus 5. and we were dividing by x minus 3. This number right here is in this form, x minus, sometimes they call it c, sometimes they call it h. It doesn't really matter what letter you use right there. But in that form, what we put in our box is just going to be h. So the opposite of this, or what would make this a 0 in some cases, would be a 3. So we'll put the 3 in the box. We'll put the coefficients. So this number, and this number, and this number are going to be our list of coefficients. So we're going to put a 1, a positive 4, a negative 5, and a positive 5. And we're ready to go. Always drop your first term down, or the first coefficient. Always, always, always drop it. It won't always be 1, but you will always drop it. And that will allow us to start our process. So you're going to take this, you can always think of it as a multiplier. Multiply this by whatever you get down here, and we're going to write it below our next term. So 3 times 1 is 3. And then we add our columns here. So I'm going to add to get to the bottom here. So 4 plus 3 is 7. And then we just start the process over again. We go back to our multiplier. 3 times 7, write it in the next spot. So we'll write a 21 there. And then we'll add our columns. So 21 minus 5, or 21 plus negative 5 is 16. And we do it once more. So 3 times 16 is 48. Add your column. So we get a 53. So if you think back to what we got in our answer, these are the coefficients that were up on the top there. And how you know what variable to give them and what degree is that they're obviously going to have x's, and you're going to start with one less than your original polynomial. So because this started as a cube, my answer is going to start as a square. And then we just keep going. So one less again would be x to the first power. And since we don't have any more variables, this is our constant, or the number that doesn't have a letter next to it. And if we're still adding numbers to our answer there, then the rest of it, that last number, would be your remainder. So hopefully you can notice that this is the exact same answer that we got. Using long division, we were just able to do it a lot simpler and a lot faster actually than using long division. So as long as you can get this process down, it takes probably a couple practices to get the hang of it. Once you got it down though, it makes division of polynomials much faster. And we'll be able to apply this when we are trying to factor and find zeros of polynomial functions. So I'll take you through one of those examples next here. So this time I'm going to try and do this division. 2x cubed minus 3x squared minus 11x plus 6. It's the square there. I'm going to try and divide that by, let's do the same division here, x minus 3. The difference in this problem sometimes might be then that they'll tell you when you're doing the division that this is a factor. If you know it's a factor, then you know you're not going to have a remainder, because if you break a number down, even if it's a polynomial, into factors, then you shouldn't have a remainder, because those two numbers are what multiply to get you back to the beginning. So if we know that this is a factor, then we shouldn't have a remainder, and this is going to help us. So again, now that we know it's a factor, we're going to put our 0 in the box. So if you know it's a factor, we'll just call it a 0 here. So the 0 of this is 3, and we just put it in our box. And now we do the same thing. List our coefficients. Drop the first one down. And multiply. So 3 times 2 is 6. Add your columns. multiply. 3 times 3 is 9. Add your column. And multiply. 3 times -2 is -6. And when we add our column here, we get 0. That's what we want. We don't want a remainder there. So these are the coefficients of your answer. We know we're going to start with 1 less than x cubed, so it's going to be x squared. This is a positive. 3x minus 2. And if we put that in a parenthesis, so in a factor form, if I were to multiply and distribute these two factors, I would get back to the beginning. So those are indeed factors of this polynomial. Two terms that when multiplied give you your original. Now I can continue to factor, and I can actually come up with the zeros of my function here. Because it's a quadratic, I'm going to use a quadratic method to factor. I know that in order to get 2x squared here, I need to multiply 2x and x. And now what's left over is just factors of -2. And if I FOIL, I should be getting this middle positive 3. Well, factors of -2, there's only 2 and 1. How am I going to get a positive 3x? I think if I make this a positive 2 here and a -1 there, I should be able to FOIL and get back to this. 2x times x is 2x squared. 2x times 2 is 4x. Minus 1x gives me my positive 3x. And -1 times 2 gives me my -2 there at the end. And now, I set it equal to 0 to find my zeros. And we just look in each set of parentheses, or set it equal to 0. X minus 3 equals 0. I know that my 0 is going to be positive 3. If I set this equal to 0, 2x minus 1 equals 0. If I add 1 and divide by 2, then I should get 1/2. And if I set this equal to 0 and solve, I should get -2. So those are my x-intercepts, or my zeros of this function. And we did that by using synthetic division. So synthetic division allowed us to factor, and we are eventually able to solve for the zeros of our function. So if you look at the graph of this on a graphing calculator, you should see the graph crossing the x-axis at 3, positive 1/2, and -2. In the next video, we're going to take this process just one more step, and we'll begin to see how we can use it to find rational zeros, and really just repeat this process to find the real zeros. So good luck using synthetic division to divide polynomials, either in problems where you have a remainder, or use synthetic division to help you factor a polynomial, in which case you don't want a remainder. That'll let you know that you came up with the factors correctly. And then just use the same process to find the zeros of the polynomial there. Alright, so there's synthetic division. Good luck using it.